Okay, so by now you should have already done the first 2 pages, right? Which means that I'll start playing the video. You should have measured out the mass of PbNO3. Okay, you should have turned that into moles for use in the BCA table. Okay, answered all the appropriate questions. You should have looked at this beaker graduated cylinder of 1 molar potassium iodide. Okay, and use the concept of molarity to figure out how many moles is in that. Okay, and then mix them together. All right, and then you should have predicted already how much of this yellow solid in here, the lead iodide, was created, okay, based on the BCA table. The mass of this lead iodide created, you should have already predicted that based on the BCA table, okay? All right, so then if we were really doing this in class, we would let this go, all right? And then we're going to filter it out, similar to how we did the copper. Remember I think it was with the nail, right? Where we drained it, right? And then we kept all that coppery stuff and then we let it dry for a while. Okay, so note here, here's the filter paper when you start. This is important. Make sure you pay attention to that. Okay, and then we're going to put it in the filter just like we did in class. Rinse it out a few times and then let it drain for a while. Okay. So what you're doing here is you're filtering, right, to separate out the 2 products. So the solid lead iodide is going to stay in the filter paper, and then what's going to drip out here at the bottom is the still aqueous potassium nitrate, okay? That part we don't care so much. We're focusing on this solid that's created, okay? All right, so you should have already, again, predicted the amount that you'd create, okay? And we're going to let it drain really well. They're going to let it dry, right, over 24 hours, just like we did in class that one time. Okay, blah, blah, blah. Okay, and then we're going to go ahead and take it out of the filter paper, right, and then put it on, and then take the mass after. Oops, that I did not want to do. I'm trying to pause it. Okay, does it pause? Oh, why does it always replay when I pause? Okay, well, whatever, you'll have to just replay yourself. Okay, all right, so you're going to then have that mass. All right, so after you did the predicted mass from the BCA table, now you're going to take what we call the actual yield, okay, which is what you're going to make actually in the lab. All right, so if you read through page 3, the mass that you calculate with the BCA table is what's called the theoretical yield. That's what you should get in a perfect world if everything goes according to plan. Okay, oftentimes in a reaction, it doesn't really go like that. You're going to have some kind of a loss somewhere. So you want to think about it and really look at this picture, okay? And you might see some places where you might see a little bit of an issue. I can pretty clearly see it myself, okay? So when you measure the actual yield, what you create in the lab, oftentimes that is less than what you thought you would make, okay? And then you can do a calculation of the percent yield, which means the percentage of what you got compared to what you thought you were going to get. Okay, and you're going to do that calculation on page 3, and then give a little bit of explanation for why do you think your percent yield is not 100? Why do you think you did not make the total amount that you thought you should make in real life in the lab? Okay, and if you see on the bottom of page 3, congratulations, we are not writing a CER for this, mainly because you do not want to write it, I do not want to grade it, and it'll be our parting gift to each other, not to have to grade it or write it. All right, and that is it.